Good?
Yep.
All right. Guys, let me go over the next concept. Okay, stay with me.
Probably press record.
Is it recording?
Yeah,
You guys make sure.
Yeah, it is.
It is?
Yep, it's counted.
Okay.
You're right. So.
In your notebooks, write down interpreting derivatives. Repeat, interpreting derivatives. It's not a difficult lesson. I will send you this document for those of you who need to. So here, does this capture?
Yeah. It captures you. I capture you. Is it recording? Yeah. Hi guys.
Okay. He says shut up. Okay, we're doing number 6. Shh. Read number 6, please. Guys, it's very wordy, so you need to pay attention. So these come in multiple choice, as well as FRQs, like they'll say interpret this. So let's read it together. It says, an economist is interested in, oh, that should say in, by the way, in how the price of a certain item affects its sales. At a price of P dollars, the quantity Q that is sold is given by that function. So write that down. So we have Q equals F of P. Q stands for quantity, and P stands for price in dollars. Okay? This has no units. The units are important. It's there in the question. It says interpret using proper units. But first, let's see if it makes intuitive sense. Intuitive sense means just common sense. Will the price of the item affect how many you sell?
Yeah.
If I raise the price, will the quantity rise or fall? Fall. Is that common sense? So those of you in econ, you know there's a price-quantity relation. Or rather, in economics, they call it demand, right? How many of you know what I'm talking about? Yeah. So again, if the price increases, demand falls, and vice versa. Is that clear? Read the question now. It says, explain the meaning of f dash of 100 equals negative 20. Because f for p. It says f dash of 100 equals negative 20. In the context of the problem, specifying units. Is that clear? No. So please understand, are we talking about the derivatives? So we are in, so hence the lesson, interpreting derivatives. Alright? Do not forget from IN3, isn't this basically delta y over delta x? In simple language, it's basically telling you how fast the y is changing. Y is nothing but quantity. How fast quantity is changing when x, say, increased by 1. Okay? How fast x is price, okay? The price. So how fast is the quantity change? In simple language. Relax, I'll call out a sentence. I will call it out. You'll say, oh my God, this is ridiculously easy. So I'm first making you understand what's going on. So in simple language, it says, as the price increases by $1, the quantity falls by 20 items. Is that clear? That's what it is in simple language. We have interpreted slopes in IN3. Again, as the price increases by 1, the quantity falls. You remember? We used to write sentences. So I'm going to call it out. And we have to write proper units. But keep in mind, this is when when the price is 100. Can you see they're giving you P to be 100. So it is smart to write down, this is P, so that's P. So the AP expectation is this. I'm speaking, so look at the board. You will interpret this number. You will give me this number in your interpretation. You will give me that number in the interpretation. And then you'll give me that units. You give me that units. So I'm going to call it out. You'll say, okay, this is ridiculous, easy. I can totally do it. So indicates that, okay, this negative 20. Indicates that. Oh, by the way, let's write units. The units are, quantity is nothing but per $1. The quantity has no units. It's just number, or number of items. That's per $1. So indicates that when the price, guys, I'm just writing left to right. When the price of an item is $100, units. When the price of an item is $100, the number, what does Q stand for? Read the question. What does Q stand for? You can say quantity, you can say number of items sold. Okay? The quantity demanded, or sales, they say quantity sold. The quantity sold is falling at the rate, remember a slope is a rate, falling at the rate of 20 over $1. Is falling at the rate of 20 units 20 units, is falling at the rate of 20 units per $1. So once again, I'm just reading it left to right in case you say what's going on. I'm just saying, look at me one final time. We will do one more example. This was one where the slope was negative. I said, oh, another small thing, clarification. Remember I said it's falling? That's why I did not say negative 20. Does that capture the negative 20 if I say falling? If it was positive, I just say rising at the rate of 20. All right? So repeat, these words are important. I'm just going left to right. Please identify, read the question to see what they stand for. Indicates that when the price of the item is $100, it says specify units. You get points for the units. The amount sold, the quantity sold, the number of items sold is falling at the rate of 20 units quantity per dollar. Yes?
No, you just.
I address it. Let's do one more for practice. Mr. Torn. No, actually we're okay. Read number 7, please. Read number 7. Yes, Mr.
Why
Mohan.
is it per $1?
Isn't price the X variable?
So it's saying that if that's the rate per.
Yeah, so as in every dollar increase, the number of items falls by 20. Units, 20 items.
Well, yeah, I get where the 20's from, but.
No, as in when the price reaches $100, guys, Morales is seeking clarification, so understand what he's saying. He's saying, what is this $1? No, we're saying, as in when the price reaches $100, so when the price, think of a graph, when the price reaches $100, if you increase the price by $1, you're going to fall by $20.
Oh, it's
20
just,
items.
it's just saying negative 20 is the slope.
Yes.
Okay.
Yes. All right, let's do another one, but this time we're choosing a positive slope. All right, so identify what those letters stand for. It is smart to identify what those letters stand for. It says W equals F of T. Okay, guys, you have to be very precise. But Lakon is not here. She sometimes will send solutions, but I'll make sure kids in the other class will get sent proper solutions. You have small things missing. Guys, I'm making this emphatically clear. Your answer should match. Oh, Miss Purcell is here. So, Miss Purcell, your solution should be tip-top, as in units here, units there, context perfect. So, I'll give you practice on this problem. So, it says, read the question. What does W stand for?
Production.
Thank you. Annual world soybean production. So that is, guys, detailed context. It is the annual world, not for the US, soybean production. Small things will mark you down. I need detailed context. How is it measured? What are my units? Read the question. Thank you. Million tons. That's the unit. Read on. Is a function of T. What does T stand for? Years since 2000. We've done this in IM3. It's years since 2000. Okay, now write on the slope. They say F dash at 6 equals positive 15. It is smart to immediately write on the units. For those of you who have forgotten from IM3 pre-calc, the unit of slope isn't it rise over run? So it's y over x units. In case you've forgotten, it's y over x units. So what are the y units? What are the y units? Million tons. What are the x units? Thank you. Years since 2000. Is that clear? Now we can write a simple sentence. Indicates that. Okay, I'm going to call out. Sharp kids who've got the hang of it, just continue writing. Like indicates that. Because guys, the interpretation goes left to right. We go left to right. It's very easy. Indicates that. So what is 6 really?
6 years after 2000.
What can we write instead? He smartly says 6 years after 2000. But what can we write instead? In 2006. So be smart, okay? Indicates that in 2006. Okay, now we're going to the right hand side. In 2006. Okay, so we are, guys, look at me. So we have done that. Now I'm coming, what's going on? In 2006.
There was.
The annual
Thank you, we're coming here. The annual world soybean production was
15
was
Increasing.
increasing. Slope, rise and run, was increasing at the rate of 15 million tons per year. Thank you. Not very clever. Repeat. In the year 2006, very well done, Mr. O. Indicates that in the year 2006, the annual world soybean production it's positive, was increasing. Don't say is. No, it's rise over run, it's change over change. increasing at the rate of 15 million tons per year. Yes, Mr. Ramesh.
Why'd you choose soybeans?
This is from the AP exam. I don't have an option.
Oh.
That's a release problem. Okay. Oh man. I have to move on to the next concept, but alright, fine. I'll just move on. Alright. Can you tell your friends in ASB to come during lunch or period 6? If they have a sport and they can miss period 6, request them to talk to a teacher. Okay, the new concept I have to discuss, because I'm thinking, okay, it's called motion. It's called motion. So basically it's calculus as applied to physics. Alright? So those of you who have taken any physics class ever will find this very, very easy. Don't get me wrong, the rest of you will also find it easy, but the physics will make connections.
No,
Alright?
the
The joke is sometimes kids say, the calculus made the physics easier to follow. Like, I understood the lesson better in physics because you taught me, right? That's what historical kids have
It
said.
does help though.
Yeah, it totally helps.
It's really good.
Yeah, alright. We're doing the calculus of motion. Shh. So we'll start with certain basic ideas. Okay, stay with me, do not fall behind. Guys, we're learning something brand new for your own sakes. Make sure come hell or high water, the homework gets done. Tomorrow you're like, whoa, that was a lot of concepts. They're not difficult though. Okay, we'll start with an easy idea. The first thing is something called position of an object. The symbol, by the way, I don't know, can some of you just speak? Is the camera able to capture this? Or it's too high?
Yeah.
No, it captures
It
it.
captures it? Thank you. The
It
symbol,
captures
you're
it.
learning something new. The symbol is S of t. Okay. For the physics kids, that's because it's really what is called displacement. Okay, it's not distance. Okay. All right. The position of an object is said to be depicted by the letter S of t at any time t. Another thing is, guys, this is motion. Now I know this is the natural world. You guys. So we will say time is greater than 0. Where I am from, time can be positive and negative. So we will assume time is only positive. Okay, so when we make number lines, look at me, when we make number lines, it's only 0 to infinity. It's actually, we will not look at negative values. We'll just erase that part of the number line that we are not interested in. Okay, next. Now these are certain basic conventions. I'm speaking to look at the board. This is convention. When the position is positive, the object is said to be right of the origin. You're right of the origin. The origin is wherever you start at. So at time equal to 0, where were you? But when the position is less than 0, you're left of the origin. So an object is moving, it starts, say, at 0. If it's moving rightwards, then the position is positive. It's going to the right. Okay, these are just basic ideas. So everybody okay so far? Okay, now we're coming to a new concept. It's called velocity. So we call it V of t. Now a simple word for you, but this is a technical physics term, but a simple word for you is speed. So think of speed, but really it's something called velocity. Okay, the velocity of an object means we're now in motion. Guys, I want to make a small clarification. Look at the board, please. Can you see this talks about position? As in, this is the origin, don't write. This is the origin, I'm at 2. The point I'm trying to make is this. The object need not be moving. Exactly, I just tell you its position is 2. Let me say that again. If the position is 2, I don't know if it's moving yet. It's just at 2. But now I'm talking about something called velocity. We are talking about motion. It has started moving around. So the point I'm trying to clarify is this. Position is very different from velocity. Velocity means the object is moving. Position is at any time, where was it? This says, well, how fast was it moving? This is convention. If velocity is positive, and you'll have to remember this. This is tricky. When the velocity is positive, the object is moving rightwards. When the velocity is positive, the object is now moving, motion, rightwards. On the other hand, when the velocity is negative, the object is moving leftwards. After you copy this, put your pencils down so let me clarify the difference between position and velocity. Because for students who are not paying very close attention, they're thinking the same things. They're not the same things. Look at me, please. You don't need to write this. You don't need to write this. Can the object be here? Okay? Is that positive position? Is that positive position? But moving leftward?
Yeah.
Okay? Do you understand that? Position and velocity are two different ideas. Likewise, could the object be here, left of the origin? In other words, the position is negative, but moving rightward, so velocity is positive. Is everybody okay with that idea? They are two very different ideas. This tells you where you are. This tells you which direction are you moving. They're two different ideas. Okay? And likewise, can I be right and moving rightwards? Or can you be left and moving leftward? That's possible too. So are there basically four possibilities? Is that common sense? Are there four different options you have? Alright. Now I am telling you, now here's the definition of velocity. I'm going to define velocity. Velocity is defined as the rate of change of position. In simple language, oh, what does that word rate mean? Derivative, thank you. So velocity is defined as the rate of change of position. Put that in a box. Okay, it's in simple language, it's nothing but the slope of the position function. So if I know position, what operation will I do to find the velocity? The derivative. Just find the derivative. It's very, very easy. Okay. Now let's talk about the next concept. You mean A? A.
Yeah, that's an MT is
Just making sure. Guys, look at the board, please. We'll do a next concept. An object is moving away from the origin. Okay, we just talked about, I don't know if you're paying very close attention, without you realizing it, we talked about four scenarios. Nobody speaks. Raise your hand and tell me, give me one scenario the object is moving away from the origin. Hint, in terms of position and velocity. Tell me one way the object can be moving away from the origin. Viramanth is raising his hand. Mr. Knight is raising his hand. Give me one way.
If it's positive and it's moving to the right,
Oh, when you say it is positive, what did you mean? What was positive?
the position
Thank you. He says the position is positive and the velocity is,
increasing or moving rightward.
or velocity is positive.
Positive.
increasing.
Is everybody okay with what he said? If my position is positive and velocity is positive, it means you're moving rightward. Will you go away from the origin? Nobody speaks. Can someone come up with another way? That's not the only way. We talked about four scenarios. Mr. Viramanth.
The position is negative.
And the velocity is?
Positive.
No, you're moving away from the origin.
Moving leftward.
So, should the position be negative and the velocity is also?
Negative.
So, stop. So, do we have a shortcut? Position and velocity. Yes. Shh. Okay, he said something, he said something. He said position is positive, velocity is positive. He said position is negative, velocity is negative. So what's our shortcut? Position and velocity should simply,
Be the same when moving.
should have the same signs. So remember that. So our discovery was S of t and V of t have the same signs. But please understand before you memorize. Don't just memorize it. Think about it. You're on the right, moving rightward. You're on the left, moving leftward. Will you move away from the origin? As a consequence of this, the next guy should be obvious. The object is moving closer to the origin. Again, are there two scenarios? Give me one scenario, Mr. Castillo. The object is moving closer to the origin.
Object is on
Talk in terms of position and velocity.
position is leftward and
Don't say leftward. Position is left. Because leftward means you're moving. Position is left. Okay, so position is negative and you're getting closer.
velocity is rightward.
Thank you. Is velocity positive? What's the second scenario, Mr. Bernal?
Oh, the position is right and the velocity is leftward.
Thank you. So what's our shortcut then, Mr. Ellis?
Well. The
Oh,
signs
okay.
are-
Yeah, the
signs
answer
are-
is yes. The answer is
the
yes.
signs-
Thank
signs
you.
are flipped.
Thank you. Should S of t and V of t have opposite signs? Is everybody okay with these ideas? Okay, I'll give you 2 minutes, memorize everything. I don't mean literally memorize, make sure you master these ideas. Repeat, we started with position. Look down please, I'm walking you through it. We started with position. Position tells you what your position is. Please do not use the word left word and right word when you talk about position. Just say left and right. Because when you say left word, we're talking as if you're moving. Alright? And that's velocity, as if we're talking motion. So that was easy. Left or right, that's it. And the next concept we discussed was velocity. Velocity is defined as the derivative of position. Is that clear? So if you have no position, take the derivative, you'll get velocity. And then we talk about left word and right word, as in you're moving now. If the velocity is positive, the object is moving rightward. If the velocity is negative, the object is moving leftward. Is that clear? And then finally, we talked about scenarios where you could be moving away from the origin. If both signs are positive, you're on the right, moving right. You're on the left, moving left. So if they have the same sign, you should be moving away. If there's opposite signs, you're moving towards. Is that obvious?
Yes.
Okay, let's do a problem before we move on. Let's do an actual problem. By the way, Mr. Ton, Mr. Fan, can you lean into the yellow sheet? Today we're following a rally schedule. No, on the wall. Tell me when this bell rings. I don't want to be in the middle of a problem. Huh? It's 13?
No, it's 15. Yeah, it's an extra minute. Well, we got first place as one.
It's 15? Thank you. Thank you.
Yeah.
Guys, it's okay. Can we move on? Like, they're breaking into a fight about 13 and 15. The girls are saying, guys. All right, guys. I'm making up a problem. Everybody, I'm making up a problem. Shh, listen. I'm making up a problem. Let S of t be 2t cubed minus, let's make it 4. 2t4 minus 3t squared. We'll do a whole bunch of problems. I'll just make them along. Okay. First, I say, let's put a 1. No, we can't put a 1. I can't put a 1. I say part A, initially. Oh, by the way, as you can see, I'm not well prepared, so I'm just writing questions on the board. Make sure you take it down, all right? Initially, is the object left or right of the origin? Nobody speaks. I will guide you. Please don't blurt out the answer. You'll kill the learning. Please do not blurt out the answer. Okay, it says initially. So what are they giving you indirectly?
Time is 0.
Time is 0. So make a note. Initially means in the beginning, when God created man. So it means time equal to 0. Okay, nobody speaks. Read this question. Don't speak yet. Is the question talking about position or velocity? And the vibe should be very clear. You shouldn't be confused. It just says, is the object on the left or on the right? So position or velocity?
Position.
Position. We're just talking about position. Of the origin. So according to Mr. Morales, so what should we just do? Just plug it in. Just by staring at it. S of 0 is?
0.
Is that a slightly tricky question?
No.
So what's our answer really? We are on the origin. Thank you. So we're actually at the origin. We're not left, we're not right. So I made that problem just to confuse you. Alright, let's do B. Let's say at t equal to 3. No, t equal to 1. Is the object left or right of the origin? So what should I just do? Yes, Mr. Arias.
Plug it in, but it's going to be left.
Okay. So S of 1 is -1. Now I'm showing you the AP explanation. Guys, this is not sufficient. The question will say explain. Each of these, the question will say explain. Is that less than 0? Therefore, object is left of the origin. Make sure you write a sentence. Object is left. If you're lazy, just say L of the origin. Not too difficult, right? Okay, let's do C, please. Now I'm raising the difficulty. Guys, every question keep constantly raising the difficulty level. C. Over what interval is the object right of the origin. Nobody speaks. Ask yourself, if you're right of the origin, what must be true? Look at the information, then raise your hand and say, Rama, do this, then the answer will show up. Nobody speaks. First do the thinking. First do the thinking. So it says, over what interval is the object right of the origin? Let's do the symbols here. So if you're right of the origin, what must be true?
Positive.
Oh, what should be positive?
Position.
Position should be positive. Look, am I indirectly solving this guy? Therefore,
Number line.
number line. What can I do?
F dash. We're not S dash. F.
Factor out of t squared.
T squared. We're already good to go.
That's the dash, is it?
No, y dash. We're talking position, silly boy.
Oh, okay.
Yeah,
So
it's
that's
a simple problem. T squared, what comes inside? 2t squared minus 3. Therefore,
T squared.
t squared
Radical t minus radical.
last step, number line. 0, radical 3 over 2, negative radical 3 over 2. Start with,
Positive.
next, negative.
Negative. Positive.
Okay, now stop. You're learning something new. Okay, what? You're learning something new. Why?
Because
It's time.
Time is 0. Time is positive. Time is positive. So let's answer the question. It says right of the origin. Therefore,
Radical three.
right of the origin. Radical 3 over 2, 2,
Positive.
infinity. Since, explanation, since,
T is greater.
since, read the question. Since S of t is greater than
That's
0.
what I said.
Yeah,
I thought you said t is greater than
No, I
0.
said since S of t.
Oh, the S was 2.
Sorry.
I
Sorry.
said it's his left.
All right, guys, let's do D, please. Shh. Let's do D, please. I say, over what interval is the object moving leftward? Nobody speaks. Read the question, think. Don't speak. Do not speak for the next 30 seconds. I want you to think about the problem. Over what interval is the object moving leftward? My first question in the class to consider is this a position question or a velocity question? If you're confused, look at this magic word. It's moving. It's in motion. So position or velocity? Velocity. So should I first find velocity? How is position and velocity related?
Dash. The
Thank
derivative
you.
of.
Can I find as dash of t?
Yeah.
Which is velocity.
I was gonna say F dash, but.
Yeah.
It's just-
Okay. Which is 8t cubed minus 6t. Now, moving leftward. So what should I do with this guy? Less than 0. And I make a number line, number line. Those are good skills. What can I factor out? Yay! 3, which is 2t minus radical 3, 2t plus radical 3. Oh, we forgot to do one thing in the previous number line. Everybody, stop what you're doing. Can you go back to the previous number line and label it as S of t, the previous one? Because we should be labeling number lines. What am I labeling this number line?
S dash of t.
V of t directly. It's the velocity number line. S dash is not wrong, but it's V of t.
Okay.
Okay, what are your 3 roots?
0. Radical 3 over 2, negative radical 3.
Start with, are they all flipping?
Positive.
Yeah.
What do I not care about?
Less than 0.
Okay. Answer the question yourself, write me a reason. It says moving leftward. 0 to,
Radical 3 over 2.
since,
T or V of t.
thank you. Guys. I don't know if you paid attention to Morales. I do. He made the connection. This is not enough. This is not enough. V of t less than 0. No. Since V of t, which was S dash of t, is less than 0. Make that connection. You're writing good notes. Make the connection. It is not obvious. It is not kind of apparent. Make the connection. The AP wants you to see, like, how did you get V of t? No, we took the derivative S dash. Make that connection. This is not too bad at all, right? Okay, last problem of the day. Write down E, please, as in EH.
Yeah.
It says, over what interval is the object moving farther away from the origin? Nobody speaks. Try not to look at your notes. Try to recall the concept. You're moving farther away from the origin. Well, hint, we discovered a shortcut. Mr. Tennyson?
The signs will be the same.
Thank you. The signs of which two quantities?
What do you mean?
No, the signs are the same. For what?
Velocity.
And
S dash of t.
S dash is velocity, and the signs, use plural. The signs need to be
Position.
and velocity. Smart kids, they need to be the same. So what should I do? Louder?
Double number line.
Nabalan, can you see the lesson I taught yesterday? There's a reason I taught that. Because they should be the same. Should we merge the number lines? Badass. So make sure you're keeping up with your homework, please. The concept will not make so much sense. Okay, somebody look down. Tell me the S roots, please. Label the S number line. Tell me the S roots. It was 0 and... We don't really care about that, do we?
Radical theory.
Like that?
Yeah.
And then what was the S dash number line? What were those roots? 0 and... No. Was it 2 over radical 3?
Radical 3.
Whoa! They were exactly the same.
No, that one's radical 3 over radical.
That's right. You're not saying it right. Which one is radical 3?
The top one.
The top one? Like that? Okay, now we have to decide which is bigger. By the way, radical 3 over 2 is smaller. Okay, so it's here actually. Everybody okay there?
Yeah.
Because here I'm just dividing a big number. There I'm dividing a small number. Should we make a sign chart? Look down, look down, look down. Look down. Draw vertical lines through all the roots. Okay, read the question again. It said moving closer or farther away? So should they have same signs or opposite signs? Same. So one interval, 0 to radical 3 over 2. Is that it?
No.
And then radical 3. No, guys, nobody is leaving. Over radical 2 to since. What's my explanation? Since S of t and V of t, which is S dash of t, have same signs. We could have same signs. Very easy lesson. Very easy lesson. Thank you. Mr. Melton, for your own sakes, do your utmost to catch up.
We're going into AOT, right?
Sorry?
We're going into AOT.
I'm going to throw in a bunch of AOT problems for homework to see how many we can.
Okay, stop recording.
Okay, yeah. Thank you.